Hello students, welcome to our YouTube channel. So the examination is around the corner, it's quite close now, and see, as I said in my last videos that I'll be coming up with the examples and the concepts, the steps involved in solving those questions, which I believe are going to be extremely important questions for this JEE main session bachon. Okay, so let's start with 3D. So I already uploaded 2 videos of expected type of questions. I mean the type of question they may ask from 3D and binomial. So now today I'll be first telling you the expected question, the question which I try to frame on my own. See, of course the data is not important. Of course I'm not saying that you are going to get exactly similar question, but I strongly believe you will get something quite close. You may get, I'm not saying you will, but you may get quite something quite close to it. Okay, so let's start with the question. The purpose of this session is not to give you the exact answer or the exact calculation, but to tell you the type of questions that can be asked and how we can approach them. Okay, so these are the questions. Like first one is find shortest distance between the lines. So 2 lines are given to us here. So find shortest distance between the lines. So that's one line, so it's 2z, of course. Okay, so it's 2z, and another one is this line. Similarly, another question is given L1, which is first line, and L2 be 2 lines. Find the equation of the line passing through A and which is parallel to the line perpendicular to both L1 and L2. Okay, so you are given 2 lines like this, something like this. They may be askew, they might not be askew. Now you have to find the equation of a line that passes through a given point and it's parallel to a line which is perpendicular to both these lines. So I will be telling you how to solve it. Okay, so these are the questions in front of you. See, the purpose here to put them in the same slide is that if you wish, you can try to solve these questions. Okay, so these are 3 questions here. Now next 2 questions are these questions, and then we have a question here, 2 questions on this slide. So from my side, I am just giving you 7 questions here. Okay, so I believe that they are going to, the concept, the steps involved in solving these questions are going to be very, very important. So stay with me till the end of the video, and it might be really helpful for you. So that's it. So let's start. Find shortest distance between these 2 lines. So the lines are 2x minus 1 by 3 is equal to 4 minus 1 by 2 is equal to 2z here, and x minus 1 by 2 is equal to 3 minus y, and z is equal to 1. See, in both the equation I have I've changed a few things. We all know that standard form of equation of line in 3D is x minus x1 by a1, and this is y minus y1 by b1 is equal to z minus z1 by c1, and we all know that whatever we have in the denominator of these ratios give us the direction ratio of the line, and these like coordinates x1 y1 z1 form the coordinates of a fixed point through which the line pass. Okay, but then you can get this information from this equation here only and only when the coefficient of x, y and z are positive 1. Okay, so what we have to ensure is here in this ratio the coefficient of x should be positive 1, here the coefficient of y should be positive 1, here the coefficient of z should be positive 1. So what will we do? We will divide both numerator and denominator by 2 here, so you get x minus half by 3 by 2 by minus 1 here, so y minus 4 by minus 2 divide by 2 here, so it's z over half. Now you can compare it. So the point through which this line L1 passes, so let's say this is line L1 here, the point through which it passes x1 y1 z1, so it's half comma 4 comma 0, and drs of the line are, so इसके drs क्या हो गया बच्चों, 3 by 2 comma minus 2 comma half here. That's one thing. Now similarly we will do for the second line. Let's say this is line L2. Now here again, see, here the coefficient of x is already positive 1, so it's okay. Here you will divide by minus 1, that's it. But what about this one? Z is equal to 1. What is it? So see, what actually is the case is, so you can write it as z minus 1 by 0. This is equal to that. Though we never write it. We shouldn't write 0 in the denominator, but see, it's not a theory paper. Okay, so I see deliberately I put this form of the part like z part coordinate here. Okay, so you should know how to tackle it if there's any confusion. So what you will do is you'll bring one this side, you have 0 in RHS and then bring 0 in the denominator, and that's your equation. So x minus 1 by 2 is equal to y minus 3 by minus 1 is equal to z minus 1 by 0. So it passes through a fixed point B, which is 1 comma 3 comma 1, and drs of second line are 2 comma minus 1 comma 0. Now how to find the shortest distance? That's a direct formula bachcho. So if you have two lines here, okay, now this passes, so I'm just writing the formula. Okay, not going to apply it bachcho, because then of course we all can apply it very easily. So it's a1 comma b1 comma c1, and this is point B, which is x2 comma y2 comma z2, and its drs are a2 comma b2 comma c2. Okay, now if you have to find the shortest distance, we should know and we should remember the shortest distance is always and always along the line which is perpendicular to both the lines. Again, I'm not going into the derivation of what we have to do. We just need to apply the formula, and the formula is shortest distance is determinant of the drs of the line segment joining the fixed points A and B. And so what will be the dr? So you can write it as x2 minus x1, y2 minus y1, and z2 minus z1. And then drs of one of the line a1 b1 c1 and drs of another line a2 b2 c2, that form the determinant of it forms the numerator, and in denominator it is magnitude of the vector which you get as the cross product of the direction vector of these two lines. So if this is the drs, these are the drs of the line, then its direction vector will be a1 I cap plus b1 j cap plus c1 k cap. Similarly, the direction vector of this line will be, whose drs are a2 b2 c2, will be a2 I cap plus b2 j cap plus c2 k cap, and just put the value here. Okay, so it's a1 b1 c1 and a2 b2 c2 here, magnitude of this vector, and of course then you put the mod here so as to ensure that this is positive. That's the formula for shortest distance. And if you are given the lines in this form, you have to convert it to the standard form so as to compare it with this form to get the coordinates of the fixed points through which both the line passes and their drs. Then you can use this formula. And one last thing, see, if the shortest distance comes out to be 0, what does that mean? That simply means that the lines are intersecting. Okay, they are not skew lines. Okay, so be ready for that type of result also. So that was the first question. Moving to the second one. Now second question is, given a line which is x minus 2 is equal to y upon minus 1 is equal to z by 2, and L2 another line which is x plus 1 by minus 2 is equal to y minus 1 by 3 is equal to z. Find equation of a line passing through a given point and which is parallel to the line perpendicular to both L1 and L2. So if I say again, see, given that line, again, though it's not required here, but still I will write here the point and the drs which we can write with the help of the equation of the line. So it passes through a fixed point which is 2 comma 0 comma 0, and drs of this line are 1 comma minus 1 comma 2. Similarly for this one, let's say it passes through the fixed point which is minus 1 comma 1 comma 0 है ना बच्चों, and drs of the second line are minus 2 comma 3 comma 1 here, because you can write as z by 1 here. Now we need a line which is parallel to the line that is perpendicular to both these lines. Okay, so if I write direction which is perpendicular to two vectors b1 and b2 vector is along b1 cross b2. I believe all of you will agree. So whenever you need a line, of course to get a line we need this direction. Whenever we need direction which is perpendicular to two given lines, two given direction vector, we can always start by taking it as b1 cross b2. So that's it. So as we have already done in the previous question, so the direction vector b1 for this line will be I cap minus j cap plus 2k cap. And the direction vector, let's say b2 will be minus 2i cap plus 3j cap plus k cap here, bachcho. Okay, so therefore, vector b, what is it? Direction vector of required line. Which line is required? A line which is perpendicular to both of them. Okay, so that is given by b1 cross b2, so I cap, j cap, k cap. And then we have it 1 comma minus 1 comma 2, and b2 is 2 3 1, bachcho, isn't that? Now you got direction of the line along which you need a line. Okay, so its direction from here, let's say I'm not going to solve it. Let's say we got b as 3i cap minus 2j cap plus k cap. So what can we say? So we can say from here, therefore drs of the line which is required, which is parallel to it, can be taken as 3 minus 2 1. See, if you need a line which is parallel to this line, then you can directly use the drs of this line. Any line which is parallel to this line, obviously you can use the drs because they themselves are the ratios. Okay, so drs of this line itself, you can use it. So therefore, equation of line, so now we can easily write it, isn't that? So what is it? Equation of line can be, okay, x minus 1 by 3 is equal to y minus 1 by minus 2 is equal to z minus 1 by 1. And I'm not claiming, okay, be careful, I just said let us say that we got this as a, you can easily get it, okay, and then you can get the drs, and hence you can solve this question. Now moving to the third one is again I use the same two lines here again. Be two lines. If L3 is if line L3 which is perpendicular to both L1 and L2 meet L1 and L2, so these are two lines. There's a line which meet L1 and L2. So this is a line L3, this is L1, this is L2, which is perpendicular to both this and this at P and Q. At P and Q. Then you have to find area of this triangle PQR, which is 1 1 1. To find area of this triangle, bachcho, what will I suggest is, I will suggest you people to find the points of intersection P and Q. Okay, now see, do we know the direction of line PQ? Do we know the direction of line PQ? Answer is yes, because PQ is perpendicular to both L1 and L2, and we already know that whenever we need a direction which is perpendicular to two directions, we will go for this. So that's it. We already know direction of the line PQ. Now, since we need here the coordinates of the point P and Q, so that's how I am approaching. See, I would have told you in that short video which you people would have got a day back, that these points might be really important, along which you get the shortest distance. Okay, see, I am repeating, we always get shortest distance between two skew lines along a line which is perpendicular to both of them. Okay, so that's it. So we will get it along the line which is perpendicular to this one also and this one also. Okay, so these points might be important. Okay, so now how will you get it? So we know one way, and the most important way, and I will say the only way rather, of using this form of equation of line in 3D is to assume a point on the line. To assume a point on the line. So I will equate all these ratio to be P. For the second line, all these ratio to be Q. Now get X from here. So what is it? So I will say it is P plus 2 minus P and 2P. Similarly here in terms of Q, if you solve it, so it's minus 2Q minus 1, 3Q plus 1 and then Q here. Okay, now can we write drs of PQ, bachcho? Answer is yes, we can. How? So we know it, and that is like x2 minus x1. So P plus 2, so it will be P plus 2Q plus 3 x2 minus x1, and then y2 minus y1. So minus P minus 3Q minus 1, and then it is z2 minus z1. So it's 2P minus Q, bachcho. Now we already know the direction of this line PQ as we have done it in this cross product here. चलिए now let's do it. कर ही लेते हैं. -1 -5 -7 if I'm not wrong, minus j cap, and then 1 minus 2 is -3, and then plus k cap, and then this is 3 plus 2 5. So it's -7 I cap plus 3 j cap plus 5 k cap. So DRs are -7 3 5. So -7 3 5. So now DRs are, so it is -7 3 5. So see, these are ratio. You can't just directly equate them. What will we do? We will just equate their ratio. So p plus q by 3 by -7 is equal to -p minus 3q minus 1 by 3 is equal to 2p minus q by 5. Solve any two of them. Let's say solve this one and that one, two equation, two unknown, you get the value of P and Q. Once you get the value for P and Q, you have these points. Once you have the points, you have the coordinates, the vertices of all the three vertices of this triangle. Then how to find the area? Be careful, you can't use determinant formula to find the area. What you can use is just simple Heron's formula. If you can use you use the distance formula to get the side line PQ, RQ and whatever they say, and then use that formula, or you may go for half base into height, but for that you need to find this distance of a point, perpendicular distance of a point from the line, and for that you need to find the equation of the line PQ here. Okay, how to find that distance we'll take up later, but then see, important thing was how to find these points, the points along which, or the line joining those 2 points along which you have the shortest distance. So that was the next question. Now moving to the next one. Fourth one is, given a line L passing through 2 points A and B. So there's a line passing through 2 points, say A, which is 1 1 1, and B, which is 2 3 4, and then this line is perpendicular to this one. Okay, so of course there's an unknown here. We can easily find unknown. How? Because two lines are perpendicular if A1 A2 plus B1 B2 plus C1 C2 is 0 here. So we can write as DRs. Of course, it's so easy to do it. So it's 1 2 3, and its DRs are, so DRs of this line are 2p -1, it's again z here bachcho, comma 1. Okay, and then A1 A2 plus B1 B2 plus C1 C2 is 0, so just do it. So it will be 2p minus 2 plus 3 equal to 0, and we have it. So p is nothing but -1/2. So that's it. Okay, so you got this line perfectly. Similarly, you will do it for this, and then you have to find the shortest distance. Okay, so once you have it, so for this you will be doing it in the, get it in the perfect form here, and then we know how to find the shortest distance. Okay, so using something else like perpendicularity condition to get the complete information about the two lines, and then to find their shortest distance between those two lines. So that was question number 4. Now moving to the fifth one. If Q is image of a point P 1 1 1 on the line, okay, so point P is 1 1 1 on the line, and the line is that itself passes through the point, say A, which is 1 0 0, and its DRs of the line are 2 1 -1 bachcho, isn't that? Then find equation of a line through A, which is 1 2 3, and A, I assume that to be A, so let me mark it as maybe something B, and parallel to PQ. So image of a point on the line. Now that's an important thing. That in itself may be a question. See, we don't need here image though in the first part at least, but that in itself may be a question. And for that, I always suggest to find this foot of perpendicular, extremely important concept. Foot of perpendicular. So what is it? The perpendicular drawn from a point on the line, bachcho. How do we do it? See, M, the foot of perpendicular, is a point on the given line. So why not to equate it with P and write any point on the line in terms of P? So we can assume it in terms of P. Since M is a point on the line itself, we can write it in terms of P. So it's 2P plus 1, P and minus P. I think it's okay. Now what? The only one condition left and which we have to use to get P, and that is, we know, we can see from here that PM is perpendicular to the line, bachcho. So PM is perpendicular to the line. So dRs of PM, so its dRs will be 2p plus 1, so it's 2p and then p minus 1 and then minus p minus 1. It is perpendicular to the line. So A1, A2, so it's 4p, B1, B2, p minus 1 and C1, C2 plus p plus 1 equal to 0. So 6p, great, 6p is equal to 0. So that means this point itself, this point is the foot of perpendicular, because when you put p equal to 0, m comes out to be 1 comma 0 comma, that's a coincidence. See, I didn't even think about it. Okay, a big great coincidence here that we got p0, if I'm not wrong. Yeah, we got p0. Okay, anyways, now you got foot of perpendicular. Then how to find the image? We know that m is midpoint of p and q. M is a midpoint of P and Q. So if I assume my coordinates of image point as alpha, beta, gamma, then it's alpha plus 1 by 2 is equal to 1, beta plus 1 by 2 is equal to 0, gamma plus 1 by 2 is equal to 0, and from here you get alpha, beta and gamma, bachcho. That's it. So what's the image here? 1 comma minus 1 comma minus 1. I can see directly, that's why I wrote it, I just wrote it. Okay. Now what do we need? Equation of a line passing through A, 1, 2, 3 and parallel to PQ. Okay, see, we don't need this thing for that, because we just even with the foot of perpendicular we have dRs of this line. Okay, so the dRs of this line, which is of course perpendicular, PQ or PM is perpendicular to the given line. Okay, then right, so it's what is it? So 0 comma minus 1 comma minus 1. So the equation of a line passing through the point x1 by 1 z1 whose dRs are a1 b1 c1. We know how to do it, we will do it. Now find point R on the given line. It should be given line such that area of triangle PQR is 10 units and R is closer to the point 1, 2, 3. So I think I need to draw that figure again. So area of triangle PQ and R. R is any point on the line. See, we have P 1, 1, 1 and coincidentally we got this one also. Together we just completed that part and to get the coordinates of P, and this is R here. Now again, see, since R is a point on the line, so we can assume it in terms of P. So let us write it as like 2P plus 1, P and minus P. So 2P plus 1, P and minus P. Okay, now this point we also know, and what is it? It's 1, 0, 0. So it's 1, 0, 0. Area half base into height. Okay, now you have PQ. So PQ length x2 minus x1 whole square. So it's under root of 0 to 4 plus 4. I think 2 root 2 if I'm not wrong. Okay, and then this distance, again using distance formula, you can find PM rather RM. And then see, I'm not 2p whole square plus p I think it's minus p, right? I'm sorry, it's minus p, right? P square plus p square, and that's it. Okay, so half base into height, whatever area is given, we will equate it to get the value of p. You will get two values of p because of this square here. So we expect to get two values of p. Now which r we need? So we will get two values of P, hence two coordinates or two different point R, then distance from the given point A1, 2, 3, whichever is closer to 1, 2, 3 is our required point here, bachcho. Okay, so that was a question based on the image, the foot of perpendicular, area of the triangle, how to use all those concepts here. Okay, now that was question number 5. Moving to next question. Right, I believe that this one might be really an important one. So distance of a point A, which is 1, 1, 1 from the line, again the line that passes through the fixed point 1 to again that's Z of course, 0, and whose dRs are 2, 3 and minus 1, bachcho. Okay, so I'll write it as Z over minus 1. Fine. Okay, now we need the equation, or rather distance of this point from the line not the perpendicular distance. See, if you have to find the perpendicular distance, then of course, as we did in this question here, if we have foot of perpendicular, we have this perpendicular distance of the point from the line. Okay, but then there's one more way of doing it, bachcho. Let me just quickly do it. There's one more way of doing it. See, if you need this distance, perpendicular distance of a point from the line, see, normally if it's just written distance of a point from the line, it inherently means the perpendicular distance, bachcho. So if you are asked to find the perpendicular distance, you already know the fixed point to which line pass. This is a right angle triangle. We already know both the given point P whose distance is required and the fixed point B from which through which the line is passing. So you have this distance, isn't that PB? Now if we get this theta, then PM, perpendicular distance, is nothing but BP sine theta. That's it. And how will you get theta? You already have drs of the given line. We can find the drs of BP, x2 minus x1, y2 minus y1, z2 minus z1, and then cos theta. From there get sine theta and put the value. You have this perpendicular distance of a point from the line. Okay, so to get perpendicular distance, it's not necessary to find foot of perpendicular, bachcho. Okay, so now move to the next one. Okay, yeah, here see, it's not the perpendicular distance which is being asked. Is what have they asked? Is, see, it's like that's the line, that's the point, and you are asked to find equation of a line, distance of this point from the line in a direction which is parallel to some line. Okay, so let's say you have to move in this direction, parallel to this direction from this point, and then the point where you meet this line, this is the required distance, bachcho. I think you got the idea. Okay, so it's not perpendicular distance, it's the distance to be calculated in some other direction. Now here there's a catch. It's not likely that you will get the distance in all possible directions. Okay, see, let's say that's the line, that's the point. If I ask you to find distance of this point from this line in this direction, now can you have a line which is parallel to this line passing through this point which meet this line? Answer is no. Answer is no. Okay, so in that case the answer is not possible. If that happens, how will we come to know whether it happens or not? See, for that what we will do is, I will write equation of line. Let's say that's the line along which I need distance. AB is the line along which I need distance. So I have to move in the direction of this vector. So that means I will assume that drs of this line is 3, minus 2, 1 point is given. So equation of AB. So it's x minus 1 by 3, y minus 1 by minus 2, z minus 1 by 1. See, to find this distance, we have to find this point and then apply 2-point distance formula. But to find this point, we have to actually find the point of intersection of this line and this line. And we know how to do it. So we will assume a point in terms of P here, any point. I didn't assume any point as P. So 2P plus 1, 3P plus 2 and minus P. And any point on this line here will be in the form, so let's say Q will be 3Q plus 1 minus 2Q, minus 2Q plus 1, and then it's Q plus 1. Now see, if at all there is a point of intersection, that means that is a common point for both the lines. So that's the common point which we are claiming. Is it there or not? That we will see later. So if there's a common point, of course their abscissa has to be same. So that's one equation. So 2P plus 1 is equal to 3Q plus 1. I think, yeah, that's the first equation. And similarly their ordinate y coordinate has to be same. So 3P plus 2, so it's 3P plus 2 is equal to minus 2Q plus 1 again, I think, plus 1 and Q plus 1 and minus P. And z coordinate, so Q plus 1 is equal to minus P must be same. See, now we have 3 equations in just 2 unknown. So why do we have one extra equation? We have it just to check the consistency. So what we will do, we will solve any 2 of them. So let's say, let's get the value of P. P is minus Q minus 1 and put it here. So we are solving these 2. Okay, so it's minus 2Q minus 2 minus 1 is equal to 3Q plus 1. So it's 5Q is equal to minus 2. So Q is minus 2 by 5. Okay, so hence P is 2 by 5 minus 1 is minus 3 by 5. Now see, to check the consistency, what are we going to do? We'll put these values of P and Q in the third equation. If these values satisfy the third equation, then only we have point of intersection, and we will get that point of intersection by putting the value of P here or Q here. Of course that will give you the same point, but let us check whether do we have it or not. So I don't think. It's minus 9 by 5 plus 2, which is 4, which is minus 1, and then you put it here, minus 4 by 5 minus plus 4 by 5 plus 1 is 9 by 5. So in RHS we get 9 by 5, in LHS we get minus 1. Of course they are not equal, so the system of equation, these three equations are not consistent. That means there is no point of intersection. So that's the case which I just told you all, or discussed with you, that if that's the line, that's the point, and you are asked to find the distance of this point from the line along this direction. So any line in this direction passing through this point won't intersect it, so that distance is not possible. Otherwise, see, if the system would have been consistent, then we will get this point of intersection by, as I said, putting P here or value of Q here, and then using 2-point distance formula we can easily find the distance of the point from the line along this direction. So that's it. So that was 6th question. Moving to the last question, I believe. Yeah, that's geometry based question. I just try to frame it. See, triangle ABC, D and E lie on AC and AB. So that's it. So that's a triangle ABC. D lie on AC such that it divides it in the ratio 1:3, and E is here somewhere. We divide AE, so in the ratio 3:1. So we have to find area of triangle ADE and area of triangle ABC, and its ratio. Of course we have to find their ratio. See, why did I take up this question? Just to tell you all that geometry part of position vector and using section formula is extremely important. Okay, because see, how will I approach? I will say that let this be the origin. That means null vector, 0 vector, its position vector. So I will say that the position vector of vertex vector B, so that means OB vector is vector B. Similarly, position vector of vertex C is vector C, so AC, so it's not OB, it's AB vector in that case, because A is the origin. Similarly, AC vector is vector C. Now using section formula, it's so simple using vector D. So it's 1 into C plus 3 into 0, so it's C vector by 4. That's the position vector of D. Similarly, position vector of E, so it's 3 into B, so 3B plus 1 into null vector by 4, and that's it. So area of triangle ABC, so area of triangle ABC is nothing but half times vector B cross vector C, bachcho, isn't that? And similarly, area of triangle ADE will be half times mod of AD cross AE, so it's C by vector C by 4 cross CB vector by 4. So how much is it? So it's 1 by 32 vector, rather 3 by 32 vector B cross C, or C cross B. Since we are talking about magnitude, they are same. So a ratio, so ratio is nothing but, so ratio is half gets cancelled. So it's 16 by 3, and that's the answer here, if I'm not wrong. Okay, calculation wise. So that's it. Okay, so those, according to me, are really the very important concepts, the steps, the type of questions for your upcoming JEE mains examination. Bachcho, with all the best wishes from our entire team. Okay, and prepare well for the examination. We'll be coming up with more such videos. See, binomial, we already gave you the concept based on which the question can be asked. I will be coming up with the questions of binomial theorem also. I will frame few questions, related question, and we'll be coming up with the video of binomial theorem as well, maybe in a day or two. Okay, chaliye, with all the best wishes, may God bless you all, bachcho.